Morning students, so in this class we are going to discuss about some introduction part of lesson number 8, dual nature of radiation and matter. So what's mean the dual nature? So it represents the particle nature as well as wave nature of radiation and matter. So what's mean that radiation? So light is an electromagnetic wave. So we get electromagnetic radiation from the sun. So that visible light, then ultraviolet, then infrared, then X-rays, gamma rays, it's come under radiation. Then matter, so matter should have a mass. So we need to know what's my particle and wave. So to understand the topics titled dual nature of radiation and matter. So what's my particle? So particle is a material object. It is considered as a tiny concentration of matter. So the matter is concentrated at some point. It is localized in space and time. So we can locate the particle with respect to the time. So example for particle is grain of sand, atoms and electrons. Then wave. So wave is a broad distribution of energy. So it is not localized in space and time, but it carry the energy and momentum from one place to another. So example for waves, sea waves, sound waves, light waves. So sea waves, so it moves up and down. Then sound waves, so sound wave is a longitudinal wave. Then light wave is a transverse wave. So sound waves propagate like compression and rarefaction. Then transverse wave, that is crust and trough. So these things we have studied in the lower classes. Then electromagnetic radiations behave as a wave in interference, diffraction and polarization. So these things we have discussed in the previous lessons. So electromagnetic radiation, that is light, behaves as a wave in interference, diffraction and polarization, but it behaves as a stream of particles in black body radiation and photoelectric effect. So a black body radiates some light. So that is black body radiation. So that radiation is acts as a stream of particles and photoelectric effect. So if you shine a light on the metal surface, some electrons are emitted, that is photoelectric effect. So we are shining some photon of energy, h mu. So that is photoelectric effect. Here the light is acts as a stream of particles. So that electromagnetic radiation behaves as a wave in interference, diffraction and polarization, but it acts as a stream of particles in black body radiation and photoelectric effect. That is dual nature of radiation and matter. So here that matter. So electron, proton and other particles are considered as the particles. They possess mass and charge. So here electron, negative charge, then proton, positive charge and other particles. So electron has some mass, then proton has some mass, but experiments showed under certain conditions that electron, protons and other particles are exhibit the wave-like property. So example for that, the direct application is electron microscope.